we will do it like this. The first function into the differential of the second function. So differential of this one is e to the power 2x into the differential of this 2x is 2, and plus the second function remains as it is into the differential of the first function, which is 2x. So we have here 2x squared e to the power 2x plus 2x e to the power 2x. Now you see that 2x and e to the power 2x is common, so we can take that outside. So if we take 2x e to the power, only x is left here and 1 is left here. Okay. Y is equal to ln of x into x plus 1 upon x plus 2 whole squared. So now here you find we have a logarithm function, we have a product, and we have a quotient. So let's do it this way. Okay, let's all first of all find out what is fx equal to. So if we find out fx, so this function will be, this whole function will be equal to fx, and then y slash will be equal to fx differential of x, differential of the function, that is f stroke x upon fx by the logarithm rule. Okay, so it's, let's see, fx is equal to x into x plus 1 upon x plus 2 whole square. So now you see, now this function becomes a algebraic expression, and once we evaluate f stroke x or the derivative of fx, we can just plug in into these two values and get the value of y, differential of y with respect to x. So let's do that. So we have here f dash x will be equal to, we can say this is equal to x squared plus x if we evaluate this one, and this is x plus 2 whole squared. So now this becomes a quotient, this becomes a fraction, so we can apply the quotient rule. So what does the quotient rule say? It is the denominator, that is x plus 2 whole squared, into the differential of the, or the derivative of the numerator. So what is the derivative of the numerator? It is 2x plus 1, 2x plus 1 minus the numerator into the derivative of the denominator. So the derivative of the denominator is 2 into x plus 2, 2 into x plus 2 into 2 minus 1, that is 1, so we will not write the 1, into the derivative of this one, that is 1. Okay, so this becomes the upon x plus 2 whole square is there, so whole square becomes 4. So this is the final derivatives. Now it is just a question of rearranging, expanding and rearranging terms to get the final value of the f stroke x. Okay, let's do that. So this becomes x plus 2 whole squared into 2x plus 1 minus x into x plus 1. I'm taking x out, common x from here, and also 2 from here, and then it is x plus 2. Okay, upon x plus 2 to the power 4. So here we feel there is two powers of x plus 2. There is one single x plus 2 here, so we can cancel 1 because it's x plus 2 is common in both, and we can cancel 1 x plus 2 from here, and this becomes 3. So now it becomes x plus 2 into 2x plus 1. So we just have to multiply this by this to get 2x squared. Let's do it in below this. So x into x, 2x is 2x squared, 4x, this 2 into 2x is 4x plus, that is 5x plus 2. So this we have found out. Now this is equal to 2x into x is 2x squared minus 2x into x is minus 2x squared, and minus 2x into plus 1 is minus 2x, right? Okay, and we have the denominators x plus 2 whole cube. So this is evaluated. So this is 2x squared. This is minus 2x squared. It cancels. 5x minus 2x is 3x. So we get a very simple expression, 3x plus 2 upon x plus 2 whole cube. So y stroke is 3x plus 2 upon x plus 2 cubed. This is divided by what? X into x plus 1. This is x into x plus 1 upon x plus 2 whole squared. Okay, so now this will become, now since this is a division, if you multiply it, it is become 3x plus 2 upon x plus 2 whole cubed multiplied by, this will go to the top, it will become x plus 2 into whole squared upon x into x plus 1. So this will become the numerator and this will become the denominator if we change this division sign into a multiplication sign. So we see here there is squared and this one cancels off. So we are left with a very simple expression, 3x plus 2 upon x plus 2 into x plus 1 into x. Okay, so this is the final answer. So now let's go ahead and do some derivatives on trigonometric expressions. So let's see this one. Y is equal to x cubed cosec x. Okay, now we see this is a trigonometric function and this is an algebraic function and we have a product of two functions. So the derivative of this function will be equal to, we'll take the first function applying the product rule. That means it is x cubed and derivative of cosine of x we get from here is cosec x minus cosec x cot x. So this is minus cosec x cot x, then plus the second function into the derivative of x cubed is 3x squared. So this becomes minus x cubed cosec x cot x plus 3x squared cosec x. Okay, let's see this one. This is a very simple one. Again, it is y is equal to cosine x upon x. Now this is a quotient, so we will apply the quotient rule for finding out the derivative. So the derivative of x is y stroke denominator into the differential of the numerator. So that is minus sine of x minus again the numerator, that is cosine of x, into the differential of the denominator, that is x is 1. So we will not write the 1, or we have to multiply this by 1 upon x squared. So this becomes minus x sine of x minus cosine of x upon x squared. Okay, so let's see this one. Y is equal to 1 upon x plus 5 cosine square x. So derivative of y is the derivative of x is equal to y stroke, which is, this is x to the power minus 1. So this will become, so we can write this as x to the power minus 1 plus 5 cosine square x. So this is very simple. So it is minus 1 x to the power minus 2. So this becomes minus 1 upon x squared, and this is 5. So this will be 2. We'll apply this rule. We'll be applying this rule. So this will be 2 cosine of x. 2 into 5 is 10. So this becomes 2 cosine of x. 2 minus 1 is 1. So, and then take the derivative of cosine of x, which is minus sine of x. Okay, so this becomes 1 upon x squared minus 10 sine of x cosine of x. We can leave it as it is, or we can apply the identity rule where 2 sine x cosine of x is equal to sine of x. So sine of 2x is equal to 2 sine x cosine of x. So this is the identity. If we apply this identity, we can change this expression into 1 upon x squared minus this 10 is taken out of 2. So we are left with 5 sine 2x. Okay. So while solving problems on differentiation, please remember all these rules and all these formulas and all these basic rules for derivatives, and you can solve any problem on differentiation. Okay, let's take one more example where it is y is equal to 2 minus cosine of x upon 2 plus cosine of x. Again, we'll apply the rule of the quotient rule. So it is 2 plus cosine of x into the differential of the numerator. So this is 0, and we know that cosine x is minus sine of x. So minus minus becomes plus. So we are left with sine of x. Now minus. Again, we'll leave the numerator as it is, and differential of 2 plus cos x is minus sine of x, because differential of 2 is 0 upon 2 plus cosine of x whole squared. Okay, so we are left with sine of x 2 sine x plus sine of x cosine of x minus, so this minus and this minus becomes plus. So we are left with 2 sine of x minus and minus, this becomes plus. So sine of x cosine of x is 2 sine x, this minus and this minus becomes plus. So sine x into 2 sine x, and it will be minus 2 minus sine x cosine of x, minus sine x cosine of x upon 2 plus cosine of x whole square. So this and this case cancels off. So we are left with 4 sine of x upon 2 plus cosine of x whole square. Okay. So these are all the exercises that are on differentiation. Okay. Thanks for watching. Till we meet in the next lecture.